Alright, so the next couple of problems we're going to work are systems of equations. The general idea is we have a pair of equations, so two equations, and they both have two variables, and they should be the same variables. All of the ones I'm going to show you have x and y, but you could have two equations that both have, I don't know, a and b, or w and t. Doesn't really matter, just as long as you have two equations and the same two variables. So the first way that we can solve these things is by graphing. If we take a look at these two equations here, we should start to remember y equals mx plus b. This is a line with a slope of a 1. If you don't see that, well, 1 times anything is itself, so that's like 1 over 1. So slope is 1, y-intercept is minus 2, and this is also a line. Y equals mx plus b. The slope here is a minus 2. And if you want to think of rise over run, you can put that over a 1. It's the same thing. So m is minus 2 and then b is a 1. I'm going to graph these two equations here, and the idea of solving by graphing is we want to see the point, the x and the y, where the two lines are going to meet. So this first one, I'm going to start off at minus 2. I'm going to put a point there. And the slope of 1 over 1 tells me from there I go up 1 and over 1, rise over run. And I can keep doing that. You really only need 2 points, but I'm just going to go ahead and label a bunch of them, or identify a bunch of them, and then just draw my line. It doesn't need to be perfect, just so I get an idea of where this thing is. Alright, so there's my first line. Second line, I'm going to start at positive 1, because that's the y-intercept, and then from there I have to go down 2 and to the right 1. So down 1, 2, over 1, oh, nice. Down 2, over 1, and so we can kind of see that these lines seems like, or I should say these lines seem to cross at the point right here, which has coordinates 1 for x and minus 1 for y. So it seems to be the case. If we want to make sure that the solution to this system of equations is the ordered pair 1 comma minus 1, we should maybe double check. So let's plug in a 1 for x. So if we plug in a 1 for x on that first equation, we get y equals 1 minus 2, and that would tell us y equals minus 1. Okay, cool. Works for the first one, but for a system of equations it has to work for both equations. So I'm going to plug into the second one as well. You can plug in the y or the x, it doesn't really matter. You just want to make sure that you get the same values when you do. So I'm going to plug in an x here of a 1, or you could plug in both and you want to make sure that you get equality either way. So I'm going to plug in a 1 for x on the second equation, and minus 2 plus 1 is a minus 1. Okay, so that in fact is the correct solution to the system of equations. Now you can write that, so you could say the solution is 1 comma minus 1, box your answer, or you could say x equals 1, y equals minus 1. Either one of these is totally fine. Now I know in Algebra 1, your teacher probably said you have to write it like this. We are going to be using algebra as a tool to solve geometry problems. More often than not, the x and the y are going to be plugged into different formulas or equations, and so it's really not necessary to write it as an ordered pair unless it says locate the point where they meet. Then we should write it as a point. Now graphing is not the most reliable method. Let me show you why. Let's say that I have another line over here that crosses this line here, and they want you to figure out the solution to the system of equations that represent each of these lines. Well, you might be saying, oh, well, that looks like 3.5 comma 1.5. Well, maybe, but it could also be like 3.4 or 3.6 or 3.417 comma 1.6278. I don't know. So the basic thing I'm getting at here is whenever you have answers that are not whole numbers, very hard to see what the actual answer is. So instead of graphing, two other methods that we're going to see. First one is, it tends to be the favorite of most students. It's called substitution. And the basic idea is we're going to take one equation, take one variable, and then get it by itself. And then once we get that answer, we have to go to the other equation and plug it in. You want to make your life easy. You don't want to overcomplicate things. For example, if I chose to solve for, let's say, y in this equation, I'd have to subtract 4x, and I'd also have to divide by -3. I'm going to end up with a bunch of fractions. Same story goes for solving for x. I could add 3y and subtract 4x, but then when I divide by that -3, I'm going to have a bunch of fractions, and fractions are annoying. So I'm going to move to this one. If I try to solve for y, I could subtract x and divide by 2. Same story, I'm going to get some fractions. However, if I try to solve for x, I can do that in one step, and I'm not going to have any fractions. So I'm going to take this equation, and I'm going to get x by itself. Not just because I like to solve for x, but just because for this particular problem, it's easier to get x by itself, and the expression I have is much simpler to work with. So x equals 5 minus 2y, or if you wanted to say minus 2y plus 5, same thing. Now that I have this by itself, I'm not going to plug it in to the same equation. It's not really going to give me anything useful. Now what I want to do is go to the other equation and substitute. In place of x, I'm going to put 5 minus 2y. So I'm going to do that right here. 4 times 5 minus 2y minus 3y is the same as minus 2. Okay, now I have one equation with one variable instead of two equations with two variables. And this is something that we saw in the last video. We reviewed how to solve these linear equations. So I'm going to distribute that 4 in. So 20 minus 8y minus 3y is the same as minus 2. I'm going to combine my like terms and get rid of this 20. So that gives me minus 11y equals, well, if I subtract 20, I get minus 22. Well, that's nice. If I divide by minus 11, I get a positive 2 for y. I might be tempted to move on to that next problem, but for a system of equations, I can't just solve for y. I need x and I need y. So now I can substitute this value in anywhere I want to. Again, you want to make your life easy. The easiest place to plug that in would be right here, because then all you got to do is use PEMDAS to simplify that thing, and then you have your value for x. So then x would be 5 minus 2 times 2. 5 minus 4 is a 1. That's it. Now if you wanted to write it as an ordered pair, make sure you use parentheses. I could say or 1 comma positive 2. If you choose to write it as an ordered pair, you have to use those parentheses, because if you don't, then you just have a list. A list is not the same as an ordered pair. An ordered pair has an order to it, x first, y second. And so the parentheses indicate you're using an ordered pair. Just to save us some time here, I'm going to leave this one as an exercise for your own time. If you want to work that one on your own and just see if you get it, you should get an answer where x is, I believe, 4, and I think y is 2. No. What did I mess up there? Is it? No. Sorry, I'm looking at the wrong thing. So work this one out on your own, see if you can get it. You should actually get x equals a 2 and y equals a 1. So I would recommend maybe picking the second equation and solving for y. A lot easier than solving for x or y in this top one. But try it out, see if you get that, and if you don't, shoot me an email or we can talk about it in class. The next method for solving linear systems is what's called elimination. This is my favorite method because it goes the fastest if you get good at it. Your prior teachers might have called it linear combination. It really means the same thing. So with elimination, the basic idea is we're going to add the equations together, or you could subtract them, and we want to eliminate one of our variables. So if I were to add the equations as is, okay, so let's see, if I did that, I would have 2x plus 1y equals 10. So I'm just going to write that up here. 2x plus y equals 10. And that's if I just add the equations as they are already. Well, that's not good because I haven't eliminated x or y. Okay, so no bueno. What I need to do is maybe some extra operation to kind of fix it up to where when I do add them together, either x cancels or y cancels. I'm going to cancel the y. You can do it any which way. There's an easy way to cancel x as well. I'm going to cancel y by taking this top equation and multiplying it by a 2. Why would I do that? Well, because if I multiply this by a 2, I'd have a minus 2 plus 2. Those are going to cancel, and then when I get the resulting equation, I only have an x in my equation. So this gives me 2x minus 2y equals a 4. Be really careful that you multiply the whole equation by a 2, not just the left side or the right side. A lot of people forget to do that. Just an easy mistake to try to avoid. And then the bottom one I did not do anything with. And you should get an 8. Okay, so now let's see what happens. If I add those together, I get 3x. And if I add these together, those cancel. Add those together, I get 12. Divide by 3. Alright, we get x equals a 4. Now what we can do is we can go to any part of our equations, plug in a 4 for x, and then solve for y. I'm going to go, I'll go up here to this one. So 4 minus y equals 2. Take away 4 on both sides. So this is going to tell us y equals a positive 2. Nice, alright, so the last one here I'll do real quick. Again, I don't have a way to cancel my x's or my y's as is. So what I'm going to do is multiply, you could either multiply the top by a minus 2 or the bottom by a 3. I'm going to multiply the top by a minus 2. Why not? So this gives you minus 2x minus 6y equals 0. 2x minus y equals 0. Now when I add together, bye x, you are gone. And I get minus 7y equals 0. Oh no, well if I divide by minus 7, I get y equals 0. And if I go back and plug that in any which way I want to, I'm going to plug it into the top one because x is pretty easy to get by itself there. Whoops, x plus 3 times 0 equals 0. Well, that means x equals 0 also. Alright, so that's it for linear systems. I'll post the last one about quadratics.